Welcome to today's episode on Switchgear Maintenance Innovation. We're exploring how ODS is enabling fast swap energy storage control with their PSME109 controller. Our expert joins us to discuss how this technology transforms the replace the device, not the wiring concept, into practical engineering reality. Let's start with the limitations of traditional energy storage setups in high voltage environments.
Traditional systems use a fragmented mix of timers, relays, and contactors that create two major bottlenecks. First, logic is spread across multiple devices, requiring extensive rewiring for any change. Second, maintenance relies heavily on operator experience rather than standardized parameters. When components fail, replacing them means dismantling wiring harnesses and disrupting adjacent circuits, costing valuable downtime.
So, the PSME109 was designed specifically for rapid field replacement. What makes its architecture fundamentally different?
It consolidates all control logic into a single standardized module with a unified terminal block. Instead of multiple devices with separate power feeds and jumpers, we've integrated start-stop interlocking, timeout stall protection into one unit. This transforms a multi-device wiring puzzle into a single reusable connection table, enabling true device changes, wiring stays maintenance.
Parameterization has been a recurring theme in ODE solutions. How does it simplify protection setup in the PSME109?
We've converted implicit operator judgments into explicit configurable parameters. Startup timeout, default 120s, stall current thresholds, 24-hour operation limits, and power loss detection. These standardized thresholds create a repeatable protection template that can be verified locally via the front panel display and reported upstream with consistent alarm codes.
What engineering details ensure reliable performance during fast swaps?
Three critical features. First, error-proof plug-type terminals with mechanical keying that prevent wiring mistakes during replacement. Second, a compact 190x72x146mm housing that fits into legacy cabinets. And third, wide environmental tolerance from -25 degrees Celsius to +70 degrees Celsius with vibration and ingress protection. These details make rapid replacement possible without disturbing existing wiring or compromising reliability.
Let's examine real-world applications. How does this simplify retrofits in legacy stations?
In one 220 kV retrofit with dense cabling, we replaced a panel with 7 discrete devices and 42 wires with a single PSME109 connected via 16 standardized terminals. The maintenance team was able to complete the swap in under 30 minutes, compared to the estimated 4 hours for traditional rewiring. The standardized terminal layout also eliminated cross-wiring errors that had caused 3 previous misoperations.
Mixed power supply environments often create compatibility issues. How does the PSME109 address this?
It accepts DC control power while supporting AC, DC, or rectified DC motor feeds, eliminating the wrong supply interface problem common in retrofits. One utility in coastal China used this flexibility to standardize on the PSME109 across both new GIS installations and older air-insulated switchgear, despite differing power systems, simplifying spare parts inventory and technician training.
Beyond faster swaps, what quantifiable engineering value does this deliver?
4 key benefits: reduced fault points through integration, parameter-driven consistency across projects, AC-DC compatibility, eliminated converter modules, and unified alarm reporting, simplifying SCADA integration. One EPC reported a 40% reduction in commissioning time for a 12-cabinet project by using the PSME109 standardized templates instead of custom relay logic.
This represents a shift from component-level to system-level thinking.
Precisely. The PSME109 turns energy storage control into a portable template-based asset that can be deployed consistently across cabinets and projects. When maintenance becomes as simple as replacing a module and verifying parameters, you transform reliability from a function of luck into a function of engineering.
For utilities standardizing their fleets, what's your call to action?
Request our PSME109 Fast Swap Implementation Kit with terminal templates and parameter baselines. Consult our engineers on supply topology optimization, and build predictable maintenance into every project from the start.
Thank you for explaining how the PSME 109 is redefining HV switchgear maintenance. Learn more at www.ods-electric.com.